So, ha ke le mole ne home teacher alone. Kan re buile ka le bona. There were 3 teachers that you kopaneng le bona, and then I discuss taba tsa maths for maths September. When you must be here. Mo meeting le ngola ka for term 3 ne ke algebra, ke geometry of straight lines. And then, yeah, I think those are the chapters that you should know. Kita baya algebra, kita baya theorem of Pythagoras, and tulia of Fumana, some of the angles of a triangle equals to 180. Some of the 2 opposite interior angles are equals to the exterior. Kita baya and body vertically opposite angles, say co-interior angles will add up to 180 degrees. And yeah, those are just a few things that you will be writing on. Come on, someone, there's only one paper that covers that entire section. Rebuwa ka algebra, rebuwa ka bo simplification, rebuwa ka factorize, rebuwa ka bo solve for x, rebuwa ka the laws of exponents. All of those things ki part ya algebra for grade 8. And then another thing we discuss it mo le bona ko meeting ke taba ya economics and management sciences, CPJ, CRJ, and then Rabuaka forms of ownership, and then Rabuaka I think forms of ownership. We taking the other one. No, a lady Oliver Hoa. I get again. Oliver Hoa qua natural science.
I'm Susan.
I'm Susan. Ole Arutang economics. Amut. Yeah. Kiena, the person in economics and management sciences, and then in this thing, natural science, electrical circuits, and sorry. So only one natural science only buyena ba hae mos wa tseba ke makgowa ona le buyena ba hae but ne re sa ela tseo ke rona nna man interest ne le hore ke fumane the information ya hore lona le hloka eng. So o buile ka practical ya electrical circuit, tlamehile le tsebe that practically you know how to calculate the current in that circuit, le tsebe the resistances and all the parallel and series circuit, just in brief summary. And then for this term, electrostatics, okay, maybe if or rubber a ruler on your jersey, on your jersey, and then you that's one practical. You pull up maybe the pieces of paper to show that the force of the magnetic field is less than the electrostatic force that is pulling the object towards that ruler. Okay? Those are just some of the things, but there will be many practical demonstrations so that you are well equipped when it comes to scientific explanations of electrostatics. That's all what you should know for term 3. So come on, someone. There's a possibility if a paper, and this is entirely your choice. You can choose to get level 1, you can choose to get level 6 or level 7. It depends on the effort that you initiate on your work. So, something in the example. So, I get to but here I think we should try and deal with geometry. Just to summarize, electrical circuits. Just to summarize. Already reviewed a parallel and series circuit, and then we also dealt with the calculations that goes with this. You remember, if maybe only way the source, the amount of energy that is to be supplied on the external circuit, and then you are given the load, the resistor, and then as current passes through that, again, it will dissipate energy by maybe the form of sound, or maybe blowing the bulb, or whatever the energy conversion may be. Now, I just want us to look at a practical demonstration, just to show how an increase in resistance affects the current that flows in the circuit, how this drains the battery, and then many of the things that revolves around that. Now, suppose we have a circuitry like this one, and the amount of voltage that is provided is 9 volts. You have resistor 1 with a value of 2 ohm and resistor 2 with a value of 3 ohms. Now you have two loads of different resistance. And then suppose that the current that is flowing in the circuit is 0.5. Now, we want to investigate something. If we increase the load, the resistors are being increased, and this is connected in series. The first thing that we would expect, if the circuit is in this configuration, we know that the total resistance of the circuit will increase, again, because how do you calculate the total resistance? The total resistance in a series circuit is equals to R1 plus R2. You are adding some of the resistances of that external circuit, and then you are just calculating the sum. Okay? By doing so, alright, 2 ohm plus 3 ohm, my dear. And I'll go from the value how keep 5 ohm. So the total resistance of the circuit has increased. Okay? Now the question is, how does this affect the voltage and the current that is flowing in the circuit? This is very, very important, because that is the SI unit of measuring current. Now, if resistance here is 5 and increase in resistance, we know the relationship that the resistance is inversely proportional to the total current that is flowing in the circuit. Okay? So, because the resistance is high, because the circuit is connected in series, we expect the total current that is flowing in the circuit to be low, provided that we have kept constant the amount of energy that the system supplies. Now, this, if we calculate the total resistance and we find it to be 5 ohm, let us try to take the same configuration but now in a parallel circuit and see exactly what the change would be. Now, if we have another circuit that is connected in parallel this time to the very same amount of energy, 9 volts, and suppose also that the current that is flowing is still 0.5 amperes, you still have 2 ohm, you still have 3 ohm. Now we know, according to the experiments, we know that in a parallel configuration, the total resistance decreases. So the total resistance will be 1 over, let's say this is R1, plus, let's say this is R2. So what is going to happen here? 1 over 2 plus 1 over 3. The LCD, you would just say 2 times 3 gives you 5. So you will have 5. And then you will just say 1 plus 1, which is 2. And then what is 2 divided by 5? Can you just try? Never. To calculate. No, 5 cannot go into 2, so it has to be 0 point something. 2 divided by 5. 0.4. Now I want you to see the difference between these two. The total resistance there was 5, but now the total resistance of the circuit is 0.4. So the total resistance of the circuit has decreased, because 2 plus 3 we would expect 5, but now the total resistance of the circuit is 0.4. So this tells us that when the resistance is inversely proportional to the total current. If the resistance is low, there would be more current that is flowing in the circuit. This is something very important. I don't think in grade 8 they would ever ask you to calculate the total resistance of a parallel circuit, but you should know it. In case ngwana grade 9 asukula ka this ukamuthusa, in case ngwana grade 10 asukula ka this ukamuthusa. And Luena, for your own understanding, it is important that you understand that. Highly and highly important. Highly and highly important. So this is exactly the effect that we have. If we have the load that is connected in parallel and we have the load that is connected in series, you would always expect that in a parallel combination, the total resistance of the circuit would decrease. Whereas in this configuration of a series connection, you would expect that the total resistance increases. Something that is worthy of noting. And then we will have a practical demonstration of this. Each learner on all those components that are necessary, and then let us try to build these different types of circuits. I will bring all of the multimeters for us to be able to see the differences. So if we increase the resistance, with the value of the multimeter, is it increasing or decreasing? We require a clear descriptive practical for us to understand this. Highly and highly important. Alright, this is just in brief summary what I wanted us to know and to understand. Now, I'm not going to go any deeper into this because Kausane, we will be dealing with previous question papers just to see exactly how this works. So, I get a book of a chance copper so that we can go to mathematics very quickly. We do not have enough time. We do not have enough.